So how are you enjoying BriForum so far? You liking it? How many of you are first-timers? It's a fair number. Okay, interesting. All right, so my name's Ian Parker, and I'm going to talk a little bit about server performance troubleshooting and benchmarking, and how to do it cheap, quick, and easy. So one of the ideas I had behind the session was, in the last few years in talking to people, it kind of seemed like, whether it was because of the financial crunch out there in the world with the global recessions or for whatever reason, it seemed like a lot of people were getting away from monitoring and benchmarking their systems. Another thing I think that might have been going on out there is a lot of us were kind of in a steady state. We were on particular products. We had hardware platforms. We were relatively comfortable with where they are. And of course, we're looking at a lot of new products and a lot of end of life and that kind of stuff. Being very cognizant of the problems there are out there with budgets, because I certainly face them as much as any of the rest of you, I wanted to find some quick and easy tools that might allow us to kind of get back into this conversation. So this is the abstract for the session, and that's a lot of words, but I think it really comes down to a couple of things, which is, if you have a new project and it performs like crap, you're not going to get any buy-in, right? If you have an existing farm or an existing system and your performance is degrading over time, you end up with a bad reputation, right? It becomes a lot harder to try to get new projects launched. And even worse, which is a situation I found myself in a few times, the performance issues that you're getting might not be for systems that are directly under your control, right? Because nothing really exists on an island anymore. You've got SQL servers that might be handling data for you. If you're doing something like publishing, Outlook to a desktop or even a published application, you're talking to an Exchange server. You may not have visibility to that because that's a messaging group, or, God knows what other stuff might be out there. And we all know what happens when you have a performance problem, right? You look at your stuff's fine. You call somebody else and they go, my stuff's fine, it must be your fault, Particularly if you're doing, a VDI or a terminal server or a Citrix workload, right? Because the reputation is always those Citrix boxes are the problem. There's never, ever been a problem with an Exchange server or a SQL server in the history of my company. It's always been the Citrix boxes. No matter what I show you, no matter what I do, those boxes have always been perfect from day one and have never had an issue. And I swear, I've actually had conversations like this where they just absolutely swear up and down it's just not possible. So what I wanted to do today is take a look at some tools, get a little hands-on, and show you, what you might be able to take home and actually use quickly and easily at home. I run a pretty casual kind of session. If anybody has any questions, feel free to raise your hand at any point. I will tell you that light's a little bright back there, so I might not see you. If I don't see you, I'm not ignoring you. Just do a jumping jack or something like that so I can see you. And I'm certainly going to try and save some time for any Q&A at the end of this, or if you're trying to desperately beat the hail or rain or whatever it is that's coming. So let's start off and talk a little bit about what the session isn't after talking about that. It's not going to be an in-depth discussion of performance and performance-related counters. Were any of you in Steve? Somebody starts arguing about time-based measurements and everything else. There's a lot of depth there and a lot of things that can be covered, but I don't want to really get into that. I want to kind of give us a high-level way of looking at things and a way of maybe establishing where an issue is to look further. And, and frankly, from my standpoint, when you get into these arguments back and forth about individual counters, just like Joe and Steve were talking about with storage, the easiest way to get around these is not to resolve the argument, it's to go find additional evidence, because people will argue forever. So sometimes you can find some additional evidence, different counters, different tools that will kind of perform a sanity check on the original data you've got. This is also not a recommendation of various server configuration options or tweaks. I'm not going to talk to you about SMB2 or 2.1 or 2.2 tuning or whatever the heck version we're going to be dealing with today. Those are certainly all very legitimate topics and very legitimate solutions to issues. But I'm kind of going to try and concentrate on identifying areas first, and then the remediation is really kind of a different conversation you might need to have. So again, what the session is, it's an introduction to some free and easy to use tools, and I'm really going to talk mostly about two tools. It's an inducement maybe to do some quick and easy baselining that you might have been neglecting. That's certainly kind of an issue in my environment. Things like baselining always get pushed off to the edge, right? The only time you ever really look at performance issues is when the house is on fire. That's pretty hard to justify spending a lot of time or money when everything is running well looking at performance or benchmarking or baselining or whatever you want to call it. There's just simply no drive behind that. But what we can do is by trying to make it easy and not take a lot of time, we can maybe still gather some information without having to go through a lot of arguments with people about resources. I'm going to assume a working familiarity with a built-in Windows Performance Monitor. If you don't have that, don't worry, because a big thrust of this is dealing with performance monitor counters. There's well over 1,000 performance monitor counters depending on what you have installed. It's an overwhelming amount of information, I think, even if you work with it on a pretty regular basis. So one of the things I'm going to try and do today is tell you ways to get around not having to memorize or know the definition of 1,000 some counters. So I talked about that a little already, but let's talk about, why do you want to use these tools? Well, the first issue is speed. If we set aside the issue of baselining for a moment and you just talk about server troubleshooting, nobody has a lot of time on their hand when there's a problem, right? I assume most of you have never had a service disruption and somebody said, hey, you know what? Take your time, the weekend's coming, go home a little early, we'll hit this back on Monday morning. If you work for a company like that, please come talk to me afterwards and let me know if you're hiring. In my situation, I have an interesting karma. When something goes wrong, it's almost always like Friday at 4:30 p.m., Wednesday at 5:20 when I need to pick up the kids from daycare in 20 minutes or something like this. It never happens on a day where my calendar's clear and it's right at 9 a.m. So, speed is important. It's important to resolve the issue. It's certainly important, I think, in terms of your own organization and building a reputation for your projects and for your existing things. Depth is another big issue. So we're in a hurry, right? We have an issue. We're trying to fix the issue. So you're trying to get something up as quick as you can. You want as much information as you can. You want to try and identify this problem quickly and move down the road to a solution. That's a reasonable goal, but that doesn't necessarily lend itself to getting a full depth of information. And one of the tough things with performance is if you skip an area, if you don't look at all the issues that are involved, you can see a symptom and think it's a cause. So, one of the kind of classic issues we see with this is disk and memory, right? You have a problem, you have a performance issue, somebody pulls up some performance counters and they go, well, look, it's disk, we need more I/O. We're back to that, that IOPS discussion we've been having a lot this week, right? It's always about I/O. Well, if you're not looking at what's going on with memory, you might actually have a concealed problem. The reason that you're having an I/O issue is because you're running out of memory. Generally speaking, right, it's a lot cheaper to add memory than it is to add storage, and particularly storage speed. So if you don't have the depth of information that you're looking at, it's easy to make a mistake and possibly go down a wrong road and a very expensive road. Consistency is another issue, particularly if you're going to look at baselining or any sort of benchmarking. You need to look at the same sorts of data, right? So you need to have a consistent data set over time. If you're doing what you think is important one day or 1 week and then you tweak that a little bit the next time, you don't have consistent information and things to look at. And consistency can save yourself a lot. Consistency, I'm using this as a little bit of a euphemism because you can save yourself from yourself. If you have a consistent set of tools, you can sometimes avoid mistakes. I had a situation once where we were testing a new application that was undergoing an update. And we had a testing plan unlike anything we'd really seen in a long time. The development team had recruited 45 actual humans who were going to sit down and test this application. They'd spent a lot of time doing scripts for these 45 people to do real workloads. So this wasn't some sort of like edge site for load testing thing where everybody was going in the same part of the program in a loop doing the same thing. This sounded great. This was mostly a project involving other people, but it was going to be on my Zen App server, so I was a little bit involved. And I probably didn't pay as much of attention as I should have. So we're going through, we're assigning resources to this. It's going in our QA environment. They wanted to isolate it a little bit from other products in QA to make sure they didn't get contaminated information. So fine, we walled them off a couple of Citrix servers, decent QA boxes, 2 processor, 8 core boxes with 12 gigs of RAM. There were 32-bit boxes. A little bit of cannibalized parts, so it was a simple RAID 1 mirror on the I/O, and we figured this was plenty. We're doing the calculations on the average amount of memory that's used by this app and the CPU, and everything looks good. We'll see how quickly you guys figure out my huge mistake here, right? So we start this project going, and everybody's got these scripts, and everything goes, and I built up a list of performance counters for it and basically handed it off to this app team and said, here, I've already built the counter logs for you. It'll start at a certain time in the morning. It'll run for a certain amount of time. Then you can look at it. If you want my help, I'll look at it, whatever. So they do this, and they start it, and I'm not really paying any attention to it, and they start calling me. Nothing's happening. We can't get on these servers. What's going on? Anybody got an idea how I goofed on this yet? So yeah, 45 people, two 32-bit terminal servers, everybody running a script and logging on in 3 minutes. So if I had paid attention to the consistency and had some disk measurements on there, we could have figured this out a lot faster. As it was, the entire test went up in flames that day, and we had to come back like a week later after the fact and figure out what happened. So yeah, even after working in this industry for a few years, I can certainly make the rookie black hole mistake. That's what I get for leaving a project in other people's hands. So why baseline? So again, if you don't have an urgent need, why do this kind of stuff? I think without any sort of frame of reference, you really can't tell where you've been and where you're going. You get into a lot of these discussions with performance stuff, right? We have a number. Maybe the disk response time is 15 milliseconds, or maybe the available memory is this number, or the disk queue length is this. Well, that's fine, and there's certainly guidelines we can use in order to figure out what we think is a problem. But if you don't have some sort of frame of reference for when things are running well, you don't have any idea where you're going, right? And I like to encourage this a lot with our developers when they put out new apps or new versions of things, right? Because I've yet to meet a developer yet who says, we're shipping a new version that's performing worse, and we're proud of that, and we know that, right? It's always something goes out, there's a problem. Inevitably, it's my problem. I did something to my servers that's the root of this problem, not the code. But if we baseline things, at least I can come back and say, the only thing that happened here is this was version 1.5 and this is version 1.7. And your average memory number before was 350 megabytes, and now it's 1.2 gigs. We have a problem, and that's not my server configuration. But I'm not going to get anywhere without hard numbers to show that to people. And I've literally had those conversations before with teams where they simply don't believe it. A lot of my developers, because the products I have are both sold externally in the market and hosted by me, they don't really spend a lot of time testing in a multi-user environment. Yes, we're significant to them, but they also have a lot of other customers that are just doing traditional LAN-based installations. So it's not ingrained into their mindset to look at multi-user. So it certainly makes troubleshooting easier. In that memory number case I gave you, unless you have some sort of frame of reference to look at where things are when things were performing well, you're not going to get anywhere. You can make an estimation that this memory number is too large, but without some sort of history or something there, it's difficult to make that case, I think. And this, I think, is maybe an underappreciated part, is unless you've got some sort of proper baseline in history, I think it's really hard to make capacity projections. A lot of my job is to try and figure out how to size things. And of course, I've always got this pressure from the data center, right? Anybody who's got any sort of significant terminal server or Zen App farm, it's typically a lot of boxes. And data centers don't like guys with a lot of boxes, right? We're always trying to shrink everything, virtualize everything, get the current draw down, get the heat load down, all the rest of that. So they always want numbers from me. And I can provide you numbers, but it becomes much easier, and my numbers become a lot more reliable when I have some sort of history to look at things. So again, without kind of knowing where you are and where you've been, your projections aren't possible. And this is something we've been going through this year. Because we were able to keep pretty good baselining numbers, I'm looking at retiring over 450 blade servers and replacing them with approximately 70. And honestly, if I didn't have good numbers on that, I never would have done that, because that's just scary to me, right? When you have that many servers and things are running well and you're talking about cutting by 75% or something like that, it's a terrifying thought. At least in my situation, it's not like I can go out and get another 100 servers racked and up in a couple of days. I'm in a large company with the data center, and the lead time for installing that kind of stuff is typically going to go into the months. And if I go into months with lousy performance, I'm dropping customers, I'm losing cash, and people are kind of asking me to justify my existence at that point. Are all benchmarks lies? How many of you see Jim Moyle's session on statistics? Yeah, that's a great session, I think. If you're interested in this stuff at all, I really recommend that you watch that session. I kind of agree with Jim. I don't like the word benchmarks. You've probably all seen at one point or another a particular vendor who tried to claim that with one of our servers you can host 700 task workers or something like that, and they show you this nice white paper on Office users and how they automated this test script and got this phenomenal Zen App density number. That's a lie. I don't know anybody that gets 700 real human beings on a server unless this is something with incredible specs that has been virtualized and got a lot of VMs stacked on it. And even then, honestly, I'm pretty suspicious. So I want to try and avoid the word benchmark if possible and call it profiling, because that's what we're really talking about here, right? We're trying to take a picture of the situation of a given set of servers or boxes, hopefully when they're performing well, but even if they aren't over time, so we can have some sort of idea to recognize when we're getting into trouble. And my personal belief is that you don't usually see performance issues in a nice linear kind of curve, right? They never go like this. You know, you don't go from a 0.8 to a 0.9 or, 0.1 sort of disk response number in a nice even kind of progression. What usually happens are these numbers get a little bit higher, but everything's okay. Things seem to be performing all right, your users are happy, you do a little testing, everything's fine, and then all of a sudden you get to a spot and it does this, right? You fall off a cliff. So that's why I think profiling is important, because these trends, what you try and monitor, are great, but at some point usually I think there's a real kind of a cliff that you fall off of. You slam into the wall. You reach a point where all of a sudden things aren't really acceptable at all. And it's only by collecting some data over time, I think, that you can figure out where that point is. Does anybody have any questions at this point? No? Okay. So the general methodology of what I want to talk about today is we want to take a tool and generate a list of counters that are useful. Once we've got that, we want to run them at the target. Not from the target, but at the target, because we don't want to screw our numbers by running these, having the data gathered on the target itself. You can certainly generate enough disk activity to bury your target server if you do enough data collection, and then you don't have any sort of valid numbers. So the idea here is to take that data collection and move it somewhere else, so that disk I/O of those BLG files from the performance monitor counters are offloaded off to that disk subsystem and not onto your test target. And then you want to do your analysis outside of production, because some of this analysis is pretty intensive. It can require a lot of CPU. Particularly when we take a look later at POW, which is essentially a bunch of PowerShell scripts that run. And it's multi-threaded and can take quite a while to chew through your data depending on the options you set. So the first thing I want to talk about is Performance Wizard, PerfWiz. How many people have 2003 boxes still somewhere in their infrastructure? That's probably at least half. Yeah, I'm in the same situation. So PerfWiz is a rather old tool. I think it probably came out around 2004. It uses existing performance monitor counters, and the nice thing about it is it still speaks the language of a lot of these older operating systems. If you're not familiar, the performance monitor process kind of changed between 2003 and 2008. The file format changed, and even when you export counters, they come out now in XML usually rather than the other formats. So it's nice to have a tool that natively speaks the 2003 language. This can be done and can be worked around. It just makes it quicker and easier. The other thing which is key, I think, to both these tools is there's virtually no install footprint. So what we're going to do is create a stack of performance counters and point it at something. It's not even really Xcopy deployable because there's nothing to deploy. You don't have to add DLLs. There's not registry settings you have to turn on or off or anything else. So you can keep your production environment relatively pristine. There's nothing worse than trying to profile or investigate a problem and find out you've made it worse by having to do something on the box, whether it's install new software or change a parameter somewhere. It creates an easily customizable performance monitor log file that can be reused. And that's another thing I was looking for in these tools is I want something simple that can get me up and running, but once I go down the road a little bit, I'm more familiar with the term, how easy is it for me to customize this and how reusable is it? We don't want to invent the wheel, right? We want to keep a tool in our toolbox that we can use pretty regularly without having to do much to. And again, I can't stress this enough, always try and remotely monitor. You really want to avoid trying to run any sort of performance analysis tool directly on the box that's having problems. It becomes very difficult to distinguish what's going on between your performance monitoring tool and what's going on between the applications that are running on the box. And there's another little thing here you have to worry about too, which is data collection. Let's just say I once heard a story about an admin who let a performance monitor counter run because he forgot to turn it off. And that starts eating up a lot of disk space. And if you run out of disk space on a production box because you're performance monitoring on it, that's kind of a hard thing to explain. Now, this certainly wasn't me or anybody I ever worked with. This is just somebody I heard about who once made that mistake. So, something to keep in mind. So again, the thing about Performance Wizard is it's old and it's mostly useful in a 32-bit world. But I think that's kind of an advantage of it. because honestly, when you've got these older 32-bit Windows 2003 servers lying around, those are the ones that maybe people aren't paying a lot of attention to, right? They've just kind of sat there and they ran and they're okay and everybody's forgotten about them because they've been there for 10 years or whatever. Well, sooner or later, they're going to reach their capacity, right? And if you've forgotten about them, it can be tough to discover. Again, that's not anything that ever happened to me or anybody I work with. It's just something I've heard or read about. So again, PerfWiz highlights. It allows you to remotely monitor a server, and I'm going to show you this in a second. And the key word here is easily. There's one key feature of the GUI which I think makes this a pretty attractive still. It has options targeted for terminal servers and Exchange, which I think is nice because you do have some rather than just looking at a generic system performance thing. It supports that customization, which I think is so important. And it allows you to specify a maximum log file size at creation so you don't run into any issues with disk space, whether it be on your production-based or not. And yes, this is GUI-based, and yes, I know that we're supposed to think GUIs are inefficient, but honestly, a GUI can be a good thing. If you're not somebody who spends all your time dealing with certain issues or certain tools, it's nice to have a nice little wizard that's next, especially when you're in a hurry. So let's take a look at PerfWiz here. It's a simple exe that you download. You get this nice little wizard. And literally it's next. This is one of the nice things about the GUI here is you can specify the monitoring computer. It defaults to local, but you can point it at anything easily enough just by typing in the server name. And when we talk about some tools later, that's not an insignificant advantage. It's not that you can't work around that, but it's quick and easy. So you can create a new log here. You have your options for a standard Perfmon, if you suspect there's a high CPU usage issue, or you can do some advanced configuration. Let's just go take a look at that option to see what's really available here. Again, I've got my options for terminal server or Exchange server here. We can specify our name. There's that nice log size, and we can even break these logs up into different files. That's another issue sometimes you might run into if these boxes aren't local to you. If you need to pull some performance data down and analyze it out of production, if you're across a WAN or something like that, that can add a significant delay to what you're doing. Your average time to issue, which lets you make some estimates on how long you think you're going to need to monitor, and your sample interval. This defaults to 30 seconds, and unless you have specific needs there, I think that's a good number to work with. A lot of performance stuff defaults to like 1 second or 3 seconds. You can start drowning yourself in data if you do that. So I think that's a decent place to look. So here are the counters that you can get out of the advanced configuration things. We have terminal server counters, lots of the traditional sorts of stuff here. If you're not a performance guy, that's fine. Just accept the defaults, or maybe add a checkbox to something that's obvious, like terminal servers. Exchange counters, I'm not an Exchange guy. I don't care. If I'm interested in an Exchange box, I'll just mark them all and move on, right? So your log status here, this is kind of nice. It lets you start, stop, or delete the log. So you actually have a GUI here for managing your data. So if you've created one here, you can immediately start it. You can even go in through here and choose an existing one you created and stopped it, or just delete for data management purposes. And since we didn't give a name, we're here, we're done. And it's really that simple. This will go ahead and create a log file out there and start it. You can use this tool to stop it, or you can go into Perfmon itself and right-click and choose Stop. And then you can pull that data into Performance Monitor and take a look at it. So the problem with this is it automates the data collection, right? But it doesn't really tell us much. Like I said, I'm not an Exchange guy. Now I've got Exchange counters and information, but where am I going to go with that, right? Now I'm reduced to Googling things and trying to figure stuff out, looking through documentation. Still tremendously useful, I think, if you're looking for the obvious thing, right? If you go in there and your CPU utilization is 100%, well, you know where you're looking at, right? Or if your disk queue length is 56 or something like that, it doesn't take a whole lot of sophistication to figure out where that is. So the genius in this, I think, is you've got an easy way to point it at a box, an easy way to get a collection of counters, and there's quite a few counters in this when you do it. You're looking at probably a wealth of information, maybe more than you're necessarily looking for. But you can get up and running. So literally almost as fast as you click through this, you can start gathering data on a problem. So whether you're troubleshooting and trying to fix something fast, or you're trying to baseline without spending any time, you've got some information here that you can look at. Anybody have any questions with PerfWiz at this point? I mean, conceptually, I think it's pretty simple and clear, right? It just automates and wraps the creation of those Perfmon logs, which is the whole thing we're looking at here. So let's move on to the next thing here, which is the performance analysis of logs. And this is really one of my favorite tools for looking at performance. So what need does PAL address? PAL kind of addresses that need I just talked about with PerfWiz, which is now I've got a bunch of data. What do I do with it? There are certain obvious things I might be able to identify, but maybe I'm not a SQL guy, or I'm not an Exchange guy, or I don't know what these counters mean. So what do I need to do at this point? I need some help with this manual data analysis. I need it analyzed faster, and hopefully with no thought on my part, or at least much less thought, right? I'm trying to isolate a problem. I need some sort of intelligence to the data I've gathered. So PAL will hopefully do that, and it will also certainly save you time. The best part about PAL, which we'll see when I demo this to you, is it consolidates a lot of various recommendations and best practices into one place. This is an issue I've run into before, where you gather some performance information, you sit down, you decide that you think this is a problem, you meet with another team or with managers or something like that, and you say, okay, look at this number. Our CPU number is this, or our disk number is this. We think that's a problem. Well, that other person in the meeting might look right back at you and say, well, I don't think that's a problem. Now, I literally had this discussion with an Exchange admin once where we were having a lot of problems with Outlook. And so we were able to run some performance counters against the Exchange server, and CPU was at 100%. Well, problem solved, right? We went into the meeting and said, look, we simply don't have enough CPU for this workload here. We need to investigate how we can knock this down. And the messaging admin kind of cocked his head and looked at me and said, well, I don't think there's a problem with 100% CPU usage. She says, there's no sign that this is backlogged. It's just fully using all of its resources. Where do you go from there, right? How many of you think 100% CPU usage is fine on a production box? Anybody? Yeah, right. So, his argument was, this isn't an interactive thing. It's a background messaging thing. What do you care if some guy takes a little longer to get his email? And I'm like, who cares? There's a 200-person call center about 50 feet that way. Why don't you ask those guys who cares? But this was something that we then came back later with PAL, and obviously that's an extreme case. That guy kind of found itself difficult to defend himself over time, but those are conversations that happen out there. Have a conversation sometimes with a SQL guy about memory usage. You want to wander around in circles for years. PAL is, again, customizable, and we'll look at that. And so the best part about this is it helps reveals all the pieces of the puzzle, right? You can take a look at a lot of different numbers and get some idea what they should mean and where you should go from there. So PAL can both be used to create and analyze Perfmon log files, and that's really where the superiority of it comes into. You can find tools out there that will create counter logs, but how about the intelligence? How about the information? Beware processing data on production hardware. The analysis process in PAL is intensive. It's PowerShell, and it's a lot of PowerShell, and it's multi-threaded, so it will take what it can get. So you certainly want to take that data and process it somewhere else. You can specify a date range within the log file, and it ships with a variety of customizable templates for Exchange, SQL, IIS, even Hyper-V and VMware, SharePoint, Active Directory, and even now a Zen App on one. Although we'll talk about that a little bit later. I think the Zen App one probably could use a little bit more work. But at least it's out there, and there's starting to be a small community that works on these things, whether it's people from Microsoft itself or whether it's people just out in the world. PAL, by the way, is hosted on CodePlex. Do you guys all know what CodePlex is? It's the open source Microsoft site. It's the brainchild of Clint Huffman, who I think is an escalation engineer at Microsoft. And he spent a lot of time over this over the last few years. The other nice thing about PAL is you can specify an analysis interval, and by that I don't mean the date range that we talked about earlier, but you can literally say, I have this chunk of performance data from 3 hours. Do I want to analyze this on a 5-second interval, a 30-second interval, a 10-minute interval? Because your intervals may really matter, right, particularly during the time of day. When I'm looking at a logon storm in the morning at 9 a.m., I'm probably a lot more interested in what the performance metrics are in my boxes every 15 seconds or 30 seconds, as opposed to maybe 2:30 in the afternoon or something like that when I might only care about 15 minutes or something like that. So it kind of gives you a way to chop up and dice the same data set over and over again and drill down where you feel like you need to drill down or back out where you don't. This is, of course, is really nice if you're doing some troubleshooting and you can actually get a time frame. When the calls come in that say, from 9 to 9:15 today, everything was terrible and then it was fine. So you can get more granularity and look at those time slices. It creates HTML-based reports. That's a code word for it. It's purdy. You can show it to managers, and they go, ooh, graphs and lines, and this is pretty, and it doesn't look like something that was thrown together by an IT guy in 10 minutes. And there's something to be said for that, right, depending on your manager. And this, I really want to hit this point over and over again. It includes some intelligence in the analysis with customizable thresholds. So PAL has its own sort of thresholds and analysis, and if you decide that, say, the number of context switches really doesn't need to be worried about at the level PAL worries about it, you can go in and customize that tool and bump the number up, or whatever might be specific to your hardware or your environment. And again, it offers the guidance and standards, and this is really priceless, I think. In many cases, it links to events and other information at Microsoft and other places to back up the analysis that it's giving. If it tells you the threshold is 10 for trouble, it'll many times give you a hyperlink out to some place where that's documented to give you additional information or additional ammunition if you're engaged in some sort of argument with another team. For the requirements on it, again, there's nothing on the target. On the analysis station, the .NET chart controls and log parser are needed. That's not bad. If you install it on a workstation yourself, it'll even prompt you where to go get this stuff so you don't have to go hunt it down yourself. There are 64 and 32-bit versions, and like everything for Microsoft at this point, right, 64-bit is current. The multi-threadedness exists only in the 64-bit versions. So that's really where you need to be, I think. The only reason not to do this is literally if you can't get your hands on a 64-bit machine somewhere, or you're in some sort of environment or something where those machines aren't available to you. If you are in that environment, the old versions are still out there on Codeplex. You can still get your hands on it. But certainly I don't think there's going to be any development of any of these additional threshold files or anything for the older versions. So let's take a look at PAL here. Again, nice, simple wizard-based stuff. You go to your counter log. Here you can specify a counter log path. So if you have existing performance monitor files, you pull them in. And this is nice. This doesn't have to be stuff that comes from PAL. This can be any performance counter log that you have. Something you made, something another guy made, anyone. It will take that data, look at it, figure out what it knows about the information in it, and process it. And if it doesn't know anything about it, it just won't do anything with it. So it's kind of Swiss Army-like in that you can hand it virtually anything. It'll chew on it and figure out what it knows about it. There's this idea here for restricting a date range. This has been useful for me in the past when I've got data for a whole day, but somebody wants to look at a half hour or something like that. So these are the threshold files that are available. It defaults to system overview, which is kind of just a generic performance thing. But these are your options it ships with, which I think are pretty significant. We've even got a Zen App one in here. There's a lot of activity in the Dynamics community. Anybody does work with Dynamics? Yeah, I think I've met like 2 guys in the world who do that, but apparently it's a really important product for Microsoft. All of this Exchange stuff, if that's something that's relevant in your environment. Even Hyper-V at this point. You've got OCS, IIS, SharePoint servers, project servers, SQL servers. Even VMware, interestingly enough. That's a relatively new addition. I wonder what the VMware guys actually think of Microsoft's comments on their performance, but that's probably something for another discussion. Here you can export right out to a Perfmon file. So if you need to create a log file from these counters, you simply go out here, choose a destination, and it'll create an XML file. That's simple enough when you go to another box. You simply go in, right-click, create new data set from file, point it at this. The one problem I think with PAL here is you notice there was no option to specify a computer name. So by default, it defaults to local. And here I want to show you a sample XML file for the Active Directory counter. So, you can work around this with a simple copy and paste. You can insert a server name simply right in front of this counter, but it is an additional step. And if you're looking at additional servers, that can be kind of a pain. It's an interesting oversight at this point, which I hope to get around to addressing. But if you're looking to do something in a hurry, that is an issue. The quick way is just take it to the box in question and run it. But again, that's not a practice that I'm particularly that wild about. I prefer to point things at servers remotely and gather the data on a non-production box. So that's something to be aware of. You can customize this here with this nice edit button. So here's the system overview. There's a bunch of process counters. You can take a look at what's here. You can get a preview of the actual description of stuff. You can even edit the charts in many places if you want to do that. I will warn you that this is an open source, non-supported tool, so there are certain parts of this with certain threshold files that will crash you out or behave not in the way that you expect. But I think overall it's pretty solid. So if you want to edit or delete any of these things in here, it's easy enough to do. And again, if you want to start creating your own customized ones, you can do inheritance, like you can take the system overview file and then add your own customization to that, or you can completely start from scratch. So it essentially gives you as much time or as much flexibility as you have time to devote to it. It gives you some questions about the environment, your number of processors, whether or not you're using the 3GB switch if you're on a 32-bit operating system. Does everybody know what 3GB switch does and boot.ini in a 32-bit box? So that changes the balance between kernel memory. You have user space and kernel space. When you add the 3GB switch, which, as far as I can remember, the only time you should ever really be doing that is under certain Exchange versions. You certainly never want to do it in the world we deal with, in a Zen App or multi-user environment, because you rob yourself of user space memory, and usually your scalability goes right out the window when you do that. Was it a 64-bit computer? And again, that affects some of these 32 versus 64-bit issues when you're analyzing address space, things like that. Total memory, can't make a calculation on available memory unless you know what the total is, right? And whether or not you've got RAID 5 or RAID 1 drives in play when you're doing disk calculations. So your output options, and again here, this is this analysis interval. It defaults to auto, which means it takes whatever amount of performance data you have and slices it up into 30 parts, whatever that might be, whether that's 7 seconds, 10 minutes, whatever. You can certainly customize this, and it wasn't immediately obvious to me why that's so great, and that's because of the processing time it takes, right? So if you want to chop things up, it chops the log file up, processes each one, moves on to the next one, processes it again. If you're in a hurry, choose like one. Just grab the data and have it take a look at everything that's there and look at your min and maxes, which you'll see later, and then you might need to make decisions about how much you want to chop this up. But in my case, one of the first times I did this, I left it at auto, and I think I had like 4 hours or something like that from a Zen App box, and it took something like 55 minutes to process all the data that I had gathered into 30 different time slices. So again, if you're in a hurry, that's something to think about. Also down here as well, process all the counters and the counter logs. So by default, if it looks at things and it doesn't see anything very interesting, it just won't put it in the report. But if you want to do things on really extensive baselining or profiling, mark that option when you're not under time crunch. When you are under a time crunch, don't leave that. It will extend your analysis time. So nothing surprising here. You get an output directory. You get to name it how you want. You can even export this out to XML if you want to do other interesting things with it. So this is the queue. This is essentially items that were set up in PowerShell. This is nothing but, I think, a description of the PowerShell things that are passed. So you can set this up to do multiple analyses if you want. If you want to run this stuff at night when you go home so it doesn't eat up a machine that you're working on, point it at 6 different log files, build it in a queue, and then you can execute. You can add things to the queue. You can execute it directly. You can execute as a low priority process. Again, if this is some sort of profiling thing you want to do, but you don't like the resource hit that it's taking, maybe if it's on your local workstation or a box in your environment that you're doing other things on, you can specify. Same thing along with the processing threads. So that's really it. I mean, it's pretty simple. And it'll pop a command window up like this. Because we weren't pointed at anything, you're getting a message here about the log parameter. But you'll just get a bunch of stuff here that gives you the status of how this goes through. So that's nice, right? But if a picture's worth 1,000 words, we have this output. Let's take a look at what something actually looks like. Yes?
So this is specifically after you've already run Perfmon
Mm-hmm.
to take a log to then analyze it. It's not actually going to start your logging first
No.
and then analyze it.
No. It will create a file that you can suck into something and start it. But it's, for an older tool with PerfWiz, which, I mean, honestly, my initial reaction was I didn't really want to talk about that because it's so old. There's some ease of use features in the thing that's 10 years old that isn't here in the current project. And I don't mean to. I've generated logs in PerfWiz, kick them off, and then just grab them when they're done and pull them back into PAL. So however you want to do it. There are some slight usability issues, I think, with PAL. So I've got a collection of some logs here that came from various environments. Some were tests, some were my own, some were from other places. Let's take a look at the Zen App one first, because that's what I do. So here's your HTML report that comes out. You get alerts by chronological order right at the top, and that just gives you kind of, I think, a quick overview of how much stuff you're going to see, right? And maybe the time frames that are there. So you get some summary stuff here. Those parameters are gone over that we talked about again, that you can verify you specified the right amount of RAM or processors, that sort of stuff. And then it starts going by alerts on chronological order. And boy, do we love our red and yellow. We don't really love it, but I suppose you at least get some idea of you know where you're going. So can you guys read that? Is it visible? Yes, no? I don't know. Let me try. If I back down screen resolution a bit here, maybe it'll be. Okay. I have to apologize. This isn't my standard laptop. I just got given something by the help desk before I left, so I'm not really sure. How's that? Is that readable? Yes? No? Better? Worse? One more? Is that better? I didn't want to get it too big because we're going to end up scrolling around quite a bit. But here you can see flat out, out of the gate here, we have greater than 25 millisecond logical disk write response time, which that has flagged as red as a critical issue. And then some other warnings about our I/O sizes. The counter itself is referenced here. Your minimum values, your average values, and your max values. I think Jim Loyal had something to say about averages. If you saw his session, that's probably worth listening to. I don't like averages, because they're arithmetic means, and when they're delivering good news. I don't mind them when they're delivering bad news. I think an average that delivers good news can hide something. When it's delivering bad news, well, things are usually really, really bad, so then I don't care so much because I'm relatively confident that my data is accurate. You've got some hourly trend information over here. And because of the way this slices up this data, it's going to take every time interval that you specified in that number that defaults to 30 and go through every one of these counters and apply its intelligence. So what that's going to do is produce a large report in most cases, unless you don't really have a problem at all. So you can see the time frames here. We work through all of this stuff. You're going to see in many cases repeated events over and over again, because in this case it looks like I was having a bit of a problem with disk performance. So every time it looks at this in this time interval, I'm going to see a lot of these things about response times, 15, 25 milliseconds, that sort of thing. We're going to talk about that a little bit later, but have you guys heard this in the past? The standard rule of thumb with disk response time is 15 milliseconds is iffy. You get to 25 milliseconds, you have a problem. Anybody heard that before? So that's kind of a standard Microsoft recommendation you'll find in a few places. I find it interesting that that was based upon the idea of a desktop machine with a 7200 RPM drive. Okay. It's not exactly what I would call current or great performing hardware, right? I mean, theoretically, I'd certainly like these expensive servers I buy to perform better than the $89 Newegg Special that was stuffed in a desktop. So again, even though we've got some guidance here and everything else, don't let that dissuade you from making your own judgments about whether that it's acceptable. To me, I certainly don't like 25 millisecond responses on my Zen App farm. I'd consider unacceptable more like 20. I get a little bit more concerned around numbers like 12 than I do about 15. But that's because I want people to pay me money every month because I operate in an ASP environment. So if you want more information on some of these things, you can just click down here and this will hyperlink you down later in the report. This will give you a description on what it is. In this case, it shows the size of the logical disk writes per second, the size of the I/O request packets, and gives you a little bit of information about this sort of stuff. Gives you a nice little graph to look at it. And here, I have to warn you, a couple of these links here are occasionally bad, and I think this one actually is bad as well. But yeah, that is. But it appears later. We'll take you. That's an example of one of these hyperlinks that will take you to some place to give you additional information. Like if we do the disk size one here. So again, we've got our description here, our 15 millisecond or 25 millisecond. For reference, ruling out disk-bound problems. So again, if you get into one of those situations where you're arguing with somebody about the significance of a number, what should be a standard, what should we look at, you can simply shell out here. And in this case, this happened to be an Exchange article. But it talks about I/O patterns, what you should actually be worried about at what levels, where these average values should be, that sort of thing. And to me, that's really kind of priceless because, again, performance stuff, to link back to Joe and Steve's session, people argue about this stuff endlessly on what's acceptable. And I think a lot of those arguments aren't necessarily driven by real numbers, they're driven by interests, right? I don't want this to be an issue with storage, so I think this number is okay. The available memory on this box, I don't want to be an issue, so maybe I think 50 megabytes is really okay. I think it goes a long way to resolving some of these issues when you can get some documentation on your side. So again, you're going to see a lot of these things here that are repeated. You've got the summaries at the top if you want to get some idea of what you're looking at. Again, you've got more than 2 IOs that are waiting on the logical disk. This particular one was basically just a whole lot of disk. So that's through the chronological alerts. Then we actually come down here again, which is that stuff we hyperlink down to and talk about, well, what does this stuff really mean? So we had lazy write flushes. Anybody know what cache lazy write flushes are? So there's this thing called the lazy writer thread in Windows. It's a low priority disk thread that when it detects that the system is idle or not busy, it tries to flush certain caches, flush information out to disk. It's essentially kind of a responsiveness thing. It's trying to do things as a lower priority task rather than interrupt the system. So in this case, I had some activity, okay? I got lines, I got graphs, okay? I can read the stuff about min and max values. But here's what I like. So essentially, the condition was okay. Here was your minimum, here was your average, your max, your hourly trend, standard deviation. Jim Moyle, thank you. I'm not even going to go there. To me, this is a little bit more interesting analysis they do. This is where they remove the outliers. So this essentially chopped off the extreme 10% on either side. Particularly useful, I think, if you're looking at like larger time intervals. So what happens if we take the 10% extreme out, or the 20%, or the 30%? So that can help you get some quick ideas on whether or not you're looking at a more systemic problem or you're looking at something that was maybe the result of a logon storm or something like that. Anybody any questions at this point? Is this making sense to you guys? Can you see how this, I think, is useful, when you're looking at these sorts of things? So this is an interesting thing about the Zen App Template they put out there. So one of the things they monitor for in their Perfmon template is license server connection failures. I would argue that that's not really a performance issue. It certainly could be an issue, and you've got grace periods and everything else, but that's not really what I would necessarily define as a performance issue. But, it's an interesting counter that they put out there. Certainly you want to fix that if you have issues, but I don't know that that's really going to cause somebody's app to run slow. So here's a specific counter for Citrix, the server resolution work item ready count. So here now we're talking about the IMA service. Here's the reference to a specific Citrix article. So again, if you need documentation, if you maybe don't know anything about server work items, this gives you a place to go and saves you time. And again, if you're trying to troubleshoot, right, this is all about speed. And if you're trying to baseline or profile, this is all about gathering information and trying to determine what is significant. So I don't know if you guys can see the scroll bar, but this goes on. There's a lot of data in this report. You're going to get an embarrassment of riches here. Again, you don't necessarily have to digest all this information if you're not troubleshooting, right? If you want to baseline this stuff, just run it, park it someplace. When you need this information, it's there for you to come back and compare to. If you're troubleshooting, you look at that summary stuff right up at the top, you figure out which counters are violating a lot or thresholding a lot, move down to the explanations and see where you can find things. Again, here, this is one of those issues why I don't really like averages when they don't report a problem. There was a problem right there. For however long that was, there was a problem. If you're looking at average values, that number is probably going to get buried and make it look like there was never a problem. But here we go. This is able to catch it, right? Your min, your average, your max, 0.43 milliseconds on disk response is certainly not reasonable. But if you take out your outliers here, yes, I did have a problem, but I didn't really have a problem all day. This is essentially saying that if I take out the worst 10%, my number is very acceptable. Not really a surprise, right? We were probably looking at some sort of logon storm there. But again, this is all about wrapping your head quickly around what was happening. So we go on and on with this sort of stuff. I think there were a couple interesting things down at the bottom. Why don't we take a quick look at some of these? So again, if you're getting into kernel memory stuff with 32-bit, this actually gives you a fairly decent description of things like pool, non-paged, and paged bytes, which if you haven't had to have experience before, that's not an intuitively obvious concept. And I would certainly argue that if you're reading out there There are a lot of people who get 32-bit kernel and user memory stuff wrong. When I first started looking at it years ago, it just drove me nuts because every person seemed to have a different opinion on it. And Raymond Chen, I think, was actually the guy from Microsoft who kind of put this to bed definitively. But you give some information, tools, additional tools you can use to go out here, like Perfmon, to take a look at kernel memory usage, and get some sort of definitive answer on this stuff. In this case, because this is a 64-bit server, I'm just not going to have those sorts of issues because of those pools. Those pools grew enormously in 64-bit address space. So once you're on 64-bit, all of that stuff really goes away. So hopefully that's really kind of an issue for the past. And again, some overall counter summary stuff at the bottom. Alerts, I love this fact here, right? No alerts found. This is a whole counter I can ignore. I don't have to pay any attention to. So that's for a Zen App box, and that's easy enough. Many of us have probably worked with those before, right? I didn't ask at the beginning. How many people work with terminal servers, Zen App servers? Right, most of you. I'm not surprised that most of you do that in a performance session, right? So again, what about the situation where we're trying to isolate things in our environment, right? Well, let's take a look at an Exchange one. And this, I got to admit, I kind of sandbagged you guys on. This was a test environment, so I generated some problems on this one using some load stress tools. So if you can see these numbers over here, right, we've got lots of alerts. And again, you see this stats only section here. This is because on this one, I marked that box to analyze all performance monitor counters. So it went and got a lot of information for statistics only that aren't necessarily going to be parsed as a problem. I don't know if you guys caught this in the window when I had up, but this is an absolutely huge log. I would say I was successful in stressing this QA server. If I can ever get to the start of this. There we go. So again, we come in here, we can verify the configurations we got, and now our alerts. So again, greater than 10 millisecond logical disk read time. I've got my min, my average, my max. That's not bad, right? 0.014 as a max. I mean, it's an issue, but it's not huge. I would say you're getting into some other issues here. RPC average latency critical. So I'm not an Exchange guy. I have no clue what that means, right? Again, I can click down on some of the stuff, get some information on the warnings, the overall counter instance things, my min, my average, my max. And again, if I take out 10% of this, all of a sudden this starts to look a lot better. So I had concerns there, but probably not for too long. And again, you can see a lot of these counters are from Exchange itself. And again, without being an Exchange admin, you probably have no idea of this stuff. And I would argue, at least in some of my experience, even when you're talking to someone whose specialty is these products, whether it's a messaging guy with Exchange or a DBA with SQL, they may have very different opinions than you do. A lot of these guys that are experts in these products tend to focus on performance metrics within the product itself. So yeah, they may be looking at RPC latencies, or the SQL guys are looking at average latch time or all this kind of stuff. And if you've worked with SQL, they've got all these DMVs, these performance DMVs inside the database that are supposed to give them all this information. Well, all that stuff's great. What you do run into occasionally is these guys are so buried in this stuff that they don't do the other simple things, right? They don't look at plain old things like disk or something like that. And I've actually had these arguments with certain people where I'm pulling one number, which is a relatively basic number in my mind. They're pulling some more advanced metrics, out of their servers that seem to indicate things are okay. And that's a lot of times when we get in these conversations where you ask them, are you having a problem? They go, no, of course not. Well, here you've got some ammunition to come back and take a look at things. There, of course, is a whole other issue about getting access to their servers to run this stuff, but that's another issue on occasion. So here we've got a deferred procedure rate calls. Anybody know what a DPC is? Yeah, I didn't really much either. So that's like an interrupt that essentially runs at a lower priority. Okay. So what does that really mean to me? Not a whole lot. But I can go through this report, I can read some of the stuff, I can click on some links, and ultimately what it comes out to is Microsoft says, this is usually a driver issue of some sort. This is usually some sort of storage or network driver that is inefficiently written. And it's not actually, in the case of a DPC, issuing a read or write, but it's some sort of control function that's managing the driver. So it's essentially a non-productive interrupt, which is why it's running at a lower level than maybe a full disk I/O interrupt. Again, thanks, pal. I wouldn't have known. But at least this gives us some sort of way to look at things. And again, this is I was really successful with some stress tools here. There's a lot of stuff here. I was able to overload the packet queue, and that's one of the reasons why I was really successful in overloading this box. Anybody have any questions at this point? No? But you see what my point here about being able to have a conversation with people and having some ammunition on your side? I would never know if I got raw data in Perfmon and graphs if this meant anything to me or not. And you could literally spend days, I think, Googling, trying to figure out where you were with this and what kind of information you could extract out of it. So here's an Active Directory one, too. There's another thing that, AD is just supposed to work, right? If you want to know about how AD problems, you should probably go watch Carl Webster's session, because I'm certainly not going to be able to tell you much. But again, if you think you're having an issue here, point this thing at it, let it do its genius, pull out these things, and give me some alerts, and give me some idea of what's going on here. Now, again, this isn't foolproof. Like, let's take a look at this one. Greater than 75% of the estimated process virtual address space. So what this is essentially saying is you've got a 2 gig address space on a 32-bit operating system, right? That's all the virtual address space that is available to a process. So that's a really high number, and it's flagging that as a warning to me. In this particular case, I wasn't actually too worried about that. Any guesses why? Because of that process, LSASS? So that's the authentication process on a domain controller. And the NTDS Active Directory database on this particular test environment happened to be around 1.1 gig. So this thing was actually trying to cache it all. It read it all into its memory. So that isn't necessarily a bad number, because it looks like it was successful in being able to cache the whole database and perform reasonably well. But it also is very close to its process address limits. So it's not necessarily an issue here, but to me this means that this is a good candidate to move up to a 64-bit DC, because we're starting to push the limits of what we can do in a 32-bit operating system efficiently by having this stuff cached in memory as opposed to having to go to disk. And this is, again, we start seeing this later. So this process is using more than 1,000 data IOs. So this starts to indicate then that, yes, we have this stuff in memory, but we're starting to see some disk activity and things like that, other indications of stress that indicate that this might be a good candidate for moving on to more scalable 64-bit hardware. Again, high context switching. Anybody run into context switching issues? Yeah, I haven't. You have. What kind of issue was it? Was it a driver or an I/O-based issue, or? It was a driver? Yeah. That's really the only time I've ever seen this. How many of you guys used Resource Manager back in the PS4 days? So like the first question everybody had when they set up, Resource Manager is, why am I read in context switches? Because the value in that was set at something like, I think the default was like 8,000 per processor or something really, really low. So anytime you actually had any sort of decent Zen app workload, past like, 2002 or 2003, you almost always went red on that. I actually talked to Barry Flanagan of Citrix at BriForum a couple of years ago, and he said once they got to quad-core processors, they never really ever found themselves limited by context switches. So to me, the most useful thing from that is probably tracking and profiling. Do you have a bad driver that's going nuts, and all of a sudden your context switches have jumped, to 200,000 or something like that from hanging around 60,000. So I just wanted to show you guys some options that are out there for what you can do with these different threshold files. Was that 5 or 10 minutes left? It's what? 15, okay. So there's a couple other things I wanted to talk about. So that's PAL in action, right? It's simple enough. I don't think this requires a whole lot of effort on anyone's part. It makes it easy enough. There are a few things to work around. So what do you want to do with this? I mean, when you get back to the office, download it, install it if it's needed, depending on where you're doing things and where you're collecting stuff. Run it a few times to establish familiarity. So if you need this in a hurry, if you're troubleshooting, archive the output that you have. So you can do some baselining, some performance. The step that I didn't put in here is then tell your boss how incredibly valuable BriForum was for you, and you need to come back next year, and they should put that in the budget right now. I just wanted to talk real quickly about counters, since I talked at the beginning about not wanting an in-depth discussion of it, but we certainly do need a little bit of framework for this. So the main counters that you're looking at are going to be processor, memory, disk, and network, right? That's the 4 kind of domains that we look at for performance. Certainly take a look at what PAL gives you, but maybe if you're not running something through PAL and you have to work faster, my favorite things for processor counters are the percent processor time, and that's the time spent executing things other than the idle thread. That'll give you some idea of how busy the processor is. It's a high-level overview. The more human interaction with the system, the more significant that number is, I think. If this is some sort of system that runs in the background, batch processing like SQL or something like that, I don't think you need to worry about that quite as much as you need your customer-facing Zen App or terminal servers. My particular view is that once you get about 70%, I think you need to do something about that. I think you're headed for that kind of falling off the cliff performance issue. I like processor queue a lot too, which is the system processor queue length counter. That indicates how much work is waiting to be processed. So you can run into situations where your percent busy is actually not bad, but you've got items in queue. And usually that's some sort of backlog or some sort of other system that you're waiting on. And that indicates that you've got actual work that's waiting to be done. And that can also give you a good idea of where you're getting on your percent processor utilization number. Once you get things into queue, then you know that you're really looking at stuff. This is a real issue. You've got things waiting to get work done. By the way, note that this is a per CPU number, so divide by your number of CPUs. Always watch this when you're talking performance monitor data. A lot of things needed to be divided by whatever's out there. So whenever your queue length is above 2 per CPU, and I include core in that definition, and you might want to include even hyper-threaded core, but that's up to you. I'm not the biggest fan of hyper-threading, although it does seem to be a lot better the last few years than it was in some of its original iterations. For the processor, by process, you can always look at process name, percent processor time. This is the easiest way to identify a process that's hogging system CPU. I have certain apps that integrate with Microsoft Office, and sometimes they don't gracefully call an exit on those products. Office seems to like to go in tight CPU loops when things aren't gracefully handled, so I see that a lot. Word, Excel, something like that will go and fully eat a core. Obviously, sustained 100% is bad, but your environment is unique. Maybe you have some reason that a process should be using 100% CPU for a half hour. It's not inconceivable for some sort of batch processing or large job, but know your environment. And this gets back to that idea of profiling, right? What's typical on my system? Memory pages per second, that's the total number of paging operations, read and writes. Always be careful when looking at these numbers to make sure that you're looking at hard page faults and not soft page faults. Everybody know the difference between a hard and soft fault? Yes, no? Maybe I ought to talk about it real quick. Hard faults mean you're really going to disk. A soft fault is typically more of a memory keeping operation where things might be moved from one process's address space to a standby list or a zero list. Those pages can be faulted back in to a process address space relatively quickly and without going to disk. So not all paging operations are equal. Those hard faults are always much worse. And it's not a lot of times very clear when you're looking at the counters if you're looking at a soft or a hard fault until you dig into the explanation. Upward trends over time usually mean add memory, right? For memory available bytes, remember memory available bytes includes things like free standby and zero lists. This is a lot more important, I think, in a 32-bit world. It's not to say it isn't important in a 64-bit world, but it certainly still is something you can keep an eye on. There are a lot of differing opinions about this. If you really want to get into it, I recommend Mark Rusinovich in the Windows Internals books. He goes over this pretty exhaustively. I like the Microsoft recommendation of adding memory if you're below 10% free on a regular basis. Now, obviously, any percentage number depends on the amount of memory you have on a box. 10% free memory on a 4 gig box is whole different from 10% memory on a 192 gig box. So, you have to exercise some judgment there. But to me, memory is so cheap, there's just not much of a reason these days to stack it in there. Lack of available memory always causes a lot of cascading failures in other systems like I/O and storage. Process name working set, that's who's using what. Watch for leaking apps, which is essentially the working set increasing over time. That can still be legitimate, but it's certainly a good indicator that you may have a problem. The whole managed code.net garbage collection procedure is an entirely different conversation. If you get into that, that's some different stuff that needs to be discussed with your development team probably. Your disk transfers for a second. I'm a big believer these days that in many cases, a lot of our Zen App boxes are really bottlenecked here on storage. Your physical disk average disk second transfers, the average response time of the disk. We talked about that a little bit earlier with the 15 millisecond and 25 millisecond times. Defragmenting is an interesting question depending on whether you're running bare metal or virtual. That's all I'll really say about that. Again, that's another discussion. And again, you might want to see Joe Schonk and Steve Greenberg's session about that. They discussed it a little too in the context of storage networking. Yeah? Yeah. Mm-hmm. And again, so watch percent idle time when you're doing physical boxes. And the key word that he said there is physical boxes. What happens to time-based performance counters when you're virtualized? They're not hypervisor aware, right? The hypervisor sits underneath that, and without offending any virtualization guys, at its simplest level, a hypervisor is essentially a time slice thing, right? Time-based counters at the OS level are completely thrown off in many cases by that. And they go both directions, sometimes good, sometimes bad. So you've got to be really careful with that when you're virtualized. And again, the disk counters are often difficult to understand. I like to come at it from multiple ways. Remember, things are handed off to RAID controllers, to SAN HBAs. All of this stuff tends to handle these things. It may hide I/O issues from you and everything else. And always, always watch for the number of spindles that are involved. Anytime you're doing a disk queue length, you want to make sure you divide that by the number of spindles. When you move into storage things like SAN arrays or even NAS filers, that becomes an almost impossible number. I don't think you want to go out and look at your LUNs and the number of spindles and try and interpret that. Try and use things that are maybe exposed by your storage vendor to get a better idea. And so again, this is just talking about disk queue length. The common mistake on this is people always forget to divide by spindles where it's relevant. Your network bytes per second. I think that's pretty straightforward. The only thing I like to point out there is that just because you have gigabit Ethernet does not mean you have gigabit throughput. There are operating system driver efficiencies and other issues that may play. So I don't like to see anything actually get close to those numbers. I don't really believe that most Windows drivers can actually give you full line speed gigabit. Maybe you've got the right combination of drivers and hardware out there, but I don't think you're getting that in most cases. And I've gone through a lot of Broadcom drivers trying to get things to work more efficiently. So other indicators on the network, again, your packet outbound and inbound errors. Errors should always be low pretty much when you're looking at anything. Your network interface output queue length is just like a disk queue length. You want those numbers to be less than the number of interfaces you have. And then there's the whole question of SMB tuning, which is probably a session or two in and of itself. Anybody have any questions? So let me open this up to you guys. What kind of tools are you using? Well, first of all, how many of you guys are using some sort of performance monitoring tool? So that's what, maybe a quarter of you? How many of you are using something supplied by the vendor that's crucial to, whether it's a Zen App thing or, Edge site or something with your storage arrays? So probably about half that number. Is anybody using a third-party tool out there to monitor stuff across their environment? I got one guy. Two. So yeah, I'm seeing a lot of that. What are you using, by the way?
Well, third party is relative. It was third party Process Explorer.
Okay.
Mark Persinovich wrote it.
So the sysinternals tool, Process Explorer?
It's not so much logging, it's something that's terribly wrong right now.
Right.
So fired up context switch delta is actually something I use all the time. That's the first thing I turn on whenever I run the app, because when you start looking for things that may be wrong that aren't obvious, context switch delta actually exposes things that might be running under radar.
Mm-hmm.
I've seen things that were killing a machine and not showing up in Task Manager at all. And it would be things because Task Manager is seeing things on a time slice in physical or
Absolutely.
virtual, and if it gets the CPU and lets it go before the clock counter comes back around again, Task Manager never sees it. It'll show up with context switch delta.
So let me try and summarize that, because I think that's a great point. So you're using Process Explorer to look at individual processes. And you're looking at context switch delta to see what's going on there. And that's a great point that that's not necessarily visible in Task Manager because that's a time slice-based utility. Those context switches may actually be happening outside of the particular slices in time, and then it may not be shown to you. I think that's also an issue with DPCs. Depending on your OS, deferred procedure calls were never exposed in Task Manager. So that stuff was completely invisible to you if you were looking through a traditional Task Manager interface. So in your case, when you saw a lot of context switches, could you trace that back to some sort of physical driver thing, or was it something in app logic, you think? Or
Probably the biggest thing
So essentially a licensing issue with an expired driver, huh?
Yeah, something like that. But I mean, it's not something that I find a whole lot all the time, but there are times where I can find really busy processes that don't appear to be busy.
Right.
Just by CPU time. Probably
Yeah. You see a lot of things sitting in a tight loop.
Yeah, and the other thing too is especially SVC host processes where Microsoft likes to hide a ton of crap in one exe.
Right.
Often difficult to figure out exactly what's even in the CPU. With Process Explorer, you can actually see every individual thread running in a process. And I've found two problems recently that I was working on where one, only through Process Explorer and looking at the threads, I could see one was a WMI call that was causing the problem. The other was Windows Server Update services.
Right. So that's a great point about SVC host, which is usually a wrapper for a lot of other processes. I wish I had this link off the top of my head, but there is a way to break SVC up into its component processes so that you can monitor that. There's an option you can set, I think, and you can force those individual services inside SVC host to run separately. But yeah, you're right. Process Explorer can certainly show you that kind of stuff and help you dig down into that a lot. So are you using anything more in a broader sense than that? Yeah, I think it's kind of tough to find some tools out there. There's some vendors out there, but you kind of have to really adjust your processes, I think, to use a lot of these large-scale performance tools. I think I'm probably just about out of time. Yeah, okay. So thanks, everybody, for coming. Please